Okay, so as I was saying, the order does matter with the quotient rule because of that minus. With the product rule, it was a plus. We were adding the two functions, so the order of addition doesn't matter. The order of subtraction does matter because one of those numbers is going to become more negative. Now, when I was learning it in high school, my calculus teacher shared this with us, and it really helped us remember it. Thinking about the high function over the low function, so it's low d high, low times the derivative, bottom function times the derivative of the top function, minus high d low, top function times the derivative of the bottom function, all over low low, or low squared. Okay, so if we have these two functions, or this function right here, this quotient, 5x minus 2 over x squared plus 1. Now, if we could simplify this algebraically, we would, but we can't. There's no factoring and canceling that can be done. We don't want to try and start moving things around or anything like that. We can't split it up. So it is a quotient rule. So y prime here is going to be low.
This time we need our JV and varsity cheerleaders to the varsity gym. Thank you.
Low times the derivative, low d high, bottom times the derivative of the top, minus high d low, top times the derivative of the bottom, all over low squared, the bottom function squared. And then we want to see if we can simplify things from there. So we're going to distribute the 5. Y prime is equal to 5x squared plus 5. We're going to distribute a negative 2x. So we've got minus 10x squared plus 4x. Okay, that's why those parentheses are there. It's very important. Leave the bottom in factored form. It's in factored form. If anything's going to simplify, we want to leave it that way so we can see if it simplifies. So let's combine like terms. We've got negative 5x squared plus 4x plus 5. I really don't think that's factorable unless I did something wrong or I'm completely overlooking something. It doesn't have a GCF. With those 5s where they're at, this is not going to factor. So we're just going to leave it the way it is. Here, there is the derivative of this function. If you really wanted to, you could factor out a negative out of the top, but it's really not necessary. Okay, so let's look at another example. Here's an interesting function. F of x is equal to 3 minus 1 over x, all over x plus 5. Now, I couldn't really work this really well with my computer, but this is really what we're looking at. Okay, this is a quotient, but we have a quotient within our quotient. So we've got to get rid of that first because we don't, I mean, technically we could take the derivative, we could change that to x to the negative 1 and we could take the derivative that way. But the easiest thing to do here is to get rid of that x, okay, get rid of this being a complex fraction. So we multiply everything by x. So our function really is 3x minus 1 over x squared plus 5x. Now, I do go ahead and distribute that because I don't have to do the product rule within my quotient rule, okay? I can, but it's a little bit of a pain. So we're just going to multiply it out so that we don't have to do the product rule within the quotient rule. So f prime of x is equal to low d high, x squared plus 5x times 3, minus high d low, 2x plus 5, all over low squared. All right, so we need to distribute and see if we can simplify. So f prime of x, I'm just keeping my notation here so that it's very clear what we're doing. Okay, distribute the 3x squared plus 15x. We've got a FOIL here, so I've got to keep that minus in front, and I need to follow it by a set of parentheses, because with that minus, after we FOIL, then we're going to have to distribute the negative. So we get 6x squared plus 15x minus 2x minus 5. And 15x plus 2x is plus 13x. I'm just saving myself some writing here. And I'm going to kind of factor the bottom, okay, because something may end up simplifying here, so I need to put that in factored form. So I'm going to take the x out, but notice it's still within a set of parentheses. Because that expression was squared, I've got to apply that squared to anything there. So let's keep working on the top. We've got 3x squared minus 6x squared, so that's minus 3x squared. We've got 15x minus 13x, so that's plus 2x. And then we've got minus a negative 5, so that's plus 5. And just for clarification purposes, I'm going to distribute that squared in the bottom. That's x squared times x plus 5 squared. I can do that here because that's a product, okay? It's not x plus 5 squared. I couldn't do it then, but because it's x times x plus 5 squared, I can apply that squared to both those terms. Let's see if we can factor that numerator. Take out a negative. We've got 3x squared minus 2x minus 5. Let's see here. Okay, so 3x and x gives us 3x squared. If we put 5 in 1 and negative 5 plus 1, we've got negative 5x on the inside plus 3x on the outside. That's going to give us negative 2x. So it does factor, but it still doesn't put it in a form where anything cancels. But it never hurts to try to find out if it does factor to simplify, because sometimes it will. Okay, sometimes it will, just in this case it didn't. So that's as far as we can take that problem right there. All right, let's do a few more, and then I'm going to let you practice with some. Let's look at this one. Y equals negative 3 times 3x minus 2x squared all over 7x. Again, I'm going to, actually with this problem, what I'm going to do is this negative 3 over 7, because it's multiplication in the top and in the bottom, I can kind of bring that in front and treat it like a constant multiple. And then now that I've kind of isolated that polynomial, do you notice that all three of those terms have an x? Okay, they all have an x in them. So let's take that out. Let's factor out that x. So really what we've got is 3 minus 2x over 1. And look, this isn't even a quotient rule problem. If we multiply that back out, we've got negative 9 over 7. Because that's over 1, so really it's just 3 minus 2x. So we've got negative 9 over 7 plus 6x over 7. So y prime here is just 6 over 7. Okay, so really complicated looking function to begin with. I mean, not really complicated, but fairly complicated. And really it's not. Like it boils down to a linear function, and so the derivative of a linear function is a constant. So you could totally do the quotient rule with this. It would just be way more work, and you'd have a lot of simplifying that you would have to do. So always look for algebraic manipulation beforehand, okay? Let's look at D, okay? G of x is equal to x squared plus 3x all over 6. Again, it looks like a quotient, but really, remember, dividing by 6 is really just multiplying by 1/6, okay? So this really isn't a quotient rule problem. This is 1/6 is a constant multiple, and the derivative of x squared plus 3x is 2x plus 3. And if you wanted to, you could distribute the 1/6 in the end. So you got 1/3 x plus 1/2. Okay, it depends on, they may put it in one form or the other. But look for things like that. They look like a quotient, but they're not really a quotient. Now, E is a quotient. I just wanted to mix our trig rule with our exponential. So let's do this. dy over dx is equal to low d high minus high times the derivative of the bottom, all over the bottom squared. What can we take out of the top there? They both have e to the x. And this is why I left the bottom the way that it is. I could have written it as e to the 2x, but I left it like that so that we could see that, oh yeah, we can cancel one of those. So we've got cosine of x minus sine of x over e to the x is our derivative for this function. Okay? Here's a take it out the door problem. try this and come back to the explanation. Write the equation of the tangent line to the function at x equals 0. So tangent line means we need slope. Slope comes from the derivative, okay, f prime of c, and then we need a point. We need an x and a y. We have x, we need y. So let's go ahead and start with that part. Let's just find our y value here. So we've got 3 times e to the 0 over 0 squared minus 3. E to the 0, anything to the 0 is 1. So we've got 3 over negative 3, so negative 1 is our y. So 0, negative 1 is our point. Let's find our derivative so that we can find our slope. So low d high minus high d low all over low squared. Now, here's an interesting thing. Typically, I would simplify the derivative, but I'm only concerned about what its value is at 0. So I'm just going to plug in 0 right here. Instead of trying to simplify and maybe mess something up, I'm just going to plug in 0 and see what I get. So that's 1, that's 0, that's 1, that's 0, that's 0. So we've got negative 3 times 3 minus 3 times 1 times 0, that's 0, over negative 3 squared. So we've got negative 9 over positive 9, which is negative 1. So our tangent line is y minus negative 1 from our y value right up here is equal to negative 1 times x minus 0. So that's y plus 1 is equal to negative x, or y is equal to negative x minus 1 if you put in the slope intercept. Okay, so here's some textbook problems for you to practice with the quotient rule.